Well, thank you everyone for taking part in the poster session. That was really lovely, and I hope you got to stay warm. It was better all standing close together, I think. So I have great pleasure now in introducing the session chair, Professor Graciela Metternicht. Graciela's been with Tern since the beginning, sort of sometimes intensively, sometimes a little bit more absent, because Graciela is on just about every committee and council in the world for the Sustainable Development Goals and things like that. Graciela is currently the Dean of Science at Western Sydney University, and before that she was at University of New South Wales, and she has participated very strongly in our remote sensing area in Tern over the years, and I have great pleasure in welcoming Graciela.
Well, thank you, Beryl, and we have quite a backup session. So without further ado, I think it's lovely that after we spoke on applications, on data, that now we have the time to sit and reflect on the impact stories, which is really essential for the future of any investment and to claim for more funding in moving forward. So the impact stories are always something that helps build a narrative around why Tern and other infrastructures need to continue to be funded. So we have a long list of speakers, and you know the gist from this morning. I will look into the live Q&A questions, and yes, where is Chad first on? So if you can move on and sit here.
The big button. All right, good afternoon, everyone. My name's Chad Burton, and I'm presenting today on behalf of myself and Professor Albert van Dijk. My badge says I'm presenting for Geoscience Australia today, but for this next 8 minutes, it's just for ANU, as this work formed part of a PhD program. So I'm going to be talking today about the processes and the results by which we operationalise the data set that we call AusEFlux. I'll just jump into it. All right. So first up, what is AusEFlux? Well, the name is just a contraction of Australian empirical fluxes, and it represents an empirical upscaling of the AusEFlux eddy covariance network. And I've just screenshot there a bit of a diagram that explains the general idea of these statistical upscalings that I grabbed from a global product. And the basic idea is that we fit machine learning models on eddy covariance, carbon and water flux data using climate and remote sensing data sets, build those models and then extrapolate them to the rest of a land surface, in this case, Australia. And that formed part of this research product that we output in 2023, which was a 1 kilometre resolution upscaling of net ecosystem exchange, gross primary productivity, and ecosystem respiration. So we developed these products for two key reasons. One, we just wanted to provide a better benchmark for terrestrial biosphere models than the existing global products that were exemplified by products like Fluxcom. And then with having a higher resolution and better product, we might be able to facilitate some new insights into Australia's carbon cycle. So having that research product out there, we then asked ourselves, is it possible for us to create an operational product? And there's a few, in asking that question, we realised there was a few enabling factors. First up, the AusEFlux network is now moderately large. I think it's upwards of 35 sites now with more than a year's worth of data. But it's key that the data has been standardised. The pre-processing of the data has been standardised across sites, thanks to the efforts of the ecosystem processes team. And that data is programmatically accessible through Tern's thread servers, which means we can automatically ingest it into models. And the other key feature is that these empirical upscaling methods themselves are also quite mature now, with it being about 15 years since the first global upscaling of the FluxNet dataset. And one of the advantages of having an operational product is that we can then, first up, we're creating ourselves a framework for the continuous improvement and refinement of these continental carbon fluxes. both through being able to periodically ingest new eddy covariance data as new sites come online, or we can just get more time series from existing sites. And we can also incorporate new and improved feature layers as they become available. So as these, like we saw in the previous session, these vegetation height layers become available, we might be able to start incorporating those sorts of things. And once we have an operational product, that can then enable us to do these rapid assessments of the climate-carbon interactions that might happen with extreme climate events without us having to spin up expensive terrestrial biosphere models. So how we went from research to an operational product, I've just screenshot and dumped the flow chart there. Don't stress, I'm not going to go through it, but it's just to give you an idea of the general steps that were involved. The key thing is that for us to have an operational product, the inputs must themselves also be operational. So in order to build it, we built it off the Oswald system that was developed to process the inputs for Tern's AusEnvironment report. So we're grabbing the climate and remote sensing data from that Oswald system to support it. And then along the way, we also made some further refinements. So we're able to refine the vegetation fractions that were going into it. So the research product, for practical reasons at the time, had a static estimate of the vegetation fractions, and this time we're able to incorporate time-varying ones with a time series decomposition method. And the upshot of that was we're also able to improve the spatial resolution. So now we're down to 500-metre resolution. So all of this is just to embed that research product into an adaptable and repeatable system. So version 2 is it represents the operational product. And these are the sort of continental scale snapshot of that, the time series. Along the top, we've got gross primary productivity and ecosystem respiration, and then the bottom is the net balance of those two things, so the net carbon uptake. I'm not going to go into any sort of research findings or anything, but just a couple of key features about AusEFlux that is an advantage over any of the global products. It does a pretty good job of representing climate-driven interannual variability, which is a persistent problem with the global products. And it does a better job of representing the typical seasonal cycle of carbon uptake in Australia, as estimated by as verified by the atmospheric conversions over Australia. And I haven't included it here, but we also have evapotranspiration estimates. So in 2024, AusEFlux was included in Tern's AusEnvironment report for the first time. So the GPP estimates and the NE estimates within that report came from this product. And this represents the first time that an estimate of net carbon uptake has been included in that estimate of Australia's national environmental health. And I just wanted to pause and just say that building this kind of product, I really think exemplifies the importance and the power of having this coordinated national data infrastructure for advancing ecosystem science. So this product itself was enabled by having all that free and open data that's easily accessible. As I mentioned, the standardisation of ecological data is a really key. The other important feature is just that it's regularly updated and versioned, which allows us to control the inputs into those models. So that's a really key feature as well, that this versioning goes on. And then critically also having access to platforms for storage of data and compute. So whether that's through Tern servers or the NCI, etc. And just as a way of demonstrating a quick use case of the data set and what's enabled by having a regularly updated product like this. So I've just tried to capture there the differences in net cumulative carbon uptake across two significant La Nina events in the 21st century. So if we look at the 2011-12 La Nina, which was heavily studied for its global impact on the carbon cycle, we saw there was a cumulative net anomaly there of around 0.8 petagrams of carbon. If we compare that with the recent triple La Nina that we experienced, the cumulative carbon uptake was about 60% of 2011-12, at about 0.5 petagrams of carbon. But however, that triple La Nina was of course coming off the back of the the tinderbox drought, which is one of the most severe on record, as well as the mega fires of 2019-20. So the carbon cycle, that cumulative uptake in that period has to be seen in the context of ecosystem recovery. And the net positive anomaly that was associated with the tinderbox drought, according to AusEFlux, was also around 0.5 petagrams of carbon. So it's not only recovered, the triple La Nina not only led to quick recovery of the carbon cycle, it's almost reversed it in just a few short years, reversed that drought anomaly in a few short years. So last slide, this version 2 was all about trying to take a research product and turn it into something that was repeatable. But for a version 3, for a subsequent version, I'd really like to focus more on trying to improve the fluxes, the quality of the flux estimates, and there's a range of areas there that I've listed. So the modelling framework is a bit unwieldy at the moment for its uncertainty calculations. We can incorporate new feature layers, incorporate new eddy-covariance flux tower sites. We need to extend it to the VIIRS satellite era with motors falling out of the sky shortly. And there might be opportunities there to improve that spatial resolution further. So if any of that is interesting to you or you think you've got ideas, I'd really love to collaborate on it. It really is a part-time project for me at this point, so I'm very open to collaborations. And just wanted to finish on a note of acknowledgement to the Tern Ecosystem Processes team and the AusEFlux site investigators, principal investigators. None of this would be possible without you, and you've built collectively an invaluable resource, so I appreciate that. Thank you.
All right. Good afternoon, everyone. Yesterday morning, Professor Andrew Campbell said something that really resonated with me. He said that we as environmental scientists who monitor species populations and environmental parameters are keepers of the long view. And I think that really beautifully encapsulates what we do as a community, and it's very apt for what we do at the Threatened Species Index, a team of which I'm part of. So today I'm going to give you a long view of the trends in our threatened and near-threatened amphibians, which were revealed by putting together Australia's first threatened frog index. Before I go on, I'd just like to acknowledge Taylor Laurie and Sarah McGrath from the TSX team for their contributions to this work, and also our RA for this work, Alex Bazina. Okay, so we're going to start by going back in time 35 years to 1990, and specifically to the wet tropics of North Queensland, and a stream that an ecologist called Martin Cohen visited to photograph this beautiful frog, the sharp-snouted day frog. And Martin knew them to be abundant at this location, and indeed later he said this. He said, "Sharp-snouted day frogs were especially abundant. If you walked down the stream, you literally had to watch and wait before each step until they hopped off the rock." Sadly, Martin Cohen was one of the last people to ever see a sharp-snouted day frog. And the reason for that is that they went very rapidly extinct as the amphibian chytrid fungus swept up the east coast of Australia. So this is some monitoring work from Keith MacDonald at Big Tableland. He was monitoring these 100-metre transects awaiting chytrid's arrival. And this is what he saw. Sharp-snouted day frogs collapsed out of those streams within 5 months. And that was true for some of the other species that he was monitoring as well. This is the common mist frog. And although it took a longer time, that species disappeared from the Big Tableland higher altitudes as well, where Keith was working. Sadly, this was a story that was repeated across southern and eastern Australia, and chytrid fungus has now caused the loss of 7 species of Australian frogs. 5 more are at imminent risk of extinction, one of which is functionally extinct in the wild, and around about 40 species were impacted and are continuing to be impacted by this fungus. But there's other threats to Australian amphibians as well. Increasingly climate change, drought, fire, the swelling of the Australian population is leading to habitat loss through urbanisation and other processes, and then invasive species as well. We've known about the impacts of introduced fish on Australia's frogs, or stream breeding frogs in particular in southern Australia for a long time, but we've got burgeoning problems with feral pigs, feral deer, etc. And so today we've got 58 taxa listed as threatened or near threatened, and that's almost a quarter of all known taxa. The good news is that these declines really stimulated a lot of research and monitoring, and there's been some really significant wins and recoveries for some species. But up until last year, what we didn't really have was an overall sense of trends for our threatened frogs. And so that's what we sought to do with the TSX, to build this frog index to understand those trends and to improve the representativeness of the index. So, firstly, of course, we had to go and gather the data, and we had two streams of effort here. The first was to identify herpetologists. These are sort of prototype herpetologists. We all look a slight variance of this. So we identified herpetologists across the country that might have data sets that we could integrate into the index. We harassed them by phone and by email asking for that data, and many of them were good enough to send us through usually an Excel spreadsheet with the data. And when I say data, what I mean here is not occurrence data, but time series of monitoring change in an abundance metric. So it might be the number of calling males, for example, at a set site for a set species using a continuous method. We then used R to collate all that data up into the format that we needed and put that into our central database. The other stream of data collection was stripping data out of the published literature. So this is a really crucial source for amphibians and generally for Australia's fauna as well. But there was lots of studies published after chytrid swept through, and we wanted to strip out the data that was in these papers as well. I've just got to say a quick thank you to two Griffith students, so Jacob Divide and Tyler Contour, who helped us with this. And then Alex built these nifty R scripts to strip the data out of plots and out of tables to integrate into our database. So from there, we had to estimate our trends once we had the data together. And in the TSX, we used the Living Planet Index methodology. I don't have time to go into the technicalities of this, but feel free to find us later and we can talk about it. But just to give you an idea, so the LPI gives you, we set a reference year, and we set our index at 1 for that reference year, and everything subsequent to that is a proportional change, the average change among the species for which we have data. And then we can get a confidence interval around that average change across species as well. So all of the plots that I'll show you look like this. Proportional change is the key thing to remember. Okay, so what did we get in terms of data? We managed to get data for 27 taxa, and that was almost half of the listed species, which we were reasonably happy with, and almost 600 time series of abundance change for our threatened and near threatened frogs. This is the spatial spread of the data, all from southern and eastern Australia, and that's due to the fact that that's where our threatened frogs are. So that's where that sort of spatial bias comes from. In terms of the species, I won't run through them all, but we got quite a bit of data for both chytrid impacted and non-impacted species. There is a raft of frogs that are threatened for other reasons and don't appear to be influenced by chytrid. But just something to note is that early in the time series, most of the data was from chytrid impacted species. So now to the national trend. It's a pretty extraordinary one, unfortunately. This is a huge decline, much larger than we see for the other groups for which we have data for, birds, mammals and plants. And you can see that precipitous decline in the data in the 1980s and 1990s, capturing that collapse of many of our frog species as chytrid swept through. and then a stabilisation and essentially a sort of waning off of that decline, but they're essentially stuck at that very low level. And I must admit, when I first saw this graph and this trend, I was worried that it wasn't capturing some of the recoveries that we'd seen in our both chytrid impacted species and non-impacted species. But if we dig into the data a little more, what we see is that those recoveries that have occurred for some populations and species are essentially swamped by continuing declines in chytrid impacted species and also non-impacted species. So if we fast forward and use a reference year of 2000, we're still seeing very substantial declines in the data, and that's after the primary period of chytrid epizootics. And as I'll show you in a moment, that relates to the fact that we're seeing significant declines now in chytrid non-impacted species as well. We have 6 national priority species under the Threatened Species Action Plan that DQ has developed, and we managed to get data for 5 of those. Their trend is equally dire as the national trend, unfortunately. So those species are in need of significant conservation help. Turning again to chytrid impacted versus non-impacted species. So if we look back at that 1985 trend, so the trend from 1985, the overall figure is about the same as the overall trend. But interestingly, if we can compare chytrid impacted and non-impacted using a reference year of 1997, that's about as far back as we can go for this comparison, we're seeing significant declines in chytrid non-impacted species. This is a noisier trend, and it's going up and down a bit. But importantly, there are strong declines in chytrid non-impacted species, and I'll talk more about that in a sec. Okay, so what does the TFX tell us? Firstly, it tells us that our threatened and near-threatened amphibians in Australia have the highest rate of decline amongst any of the groups that we've compiled data for so far in the TSX. It tells us that our threatened and near-threatened frogs are continuing to decline overall, unfortunately. And as I say, this relates to sort of new declines in chytrid non-impacted species. Things like Wallam sedge frogs in southeast Queensland, northern New South Wales, Kuranda tree frogs, a species that lives up in the rainforest on the plateau, is declining very sharply, not thought to be due to chytrid. The sunset frog in WA declining very sharply. This is a species that's impacted by ongoing droughts and fire, and that species was a great surprise to me that is declining quite sharply as well, but understandable in the impacts of when you think about the threats that it's facing. The other thing that this process tells us is that we need to keep building the taxonomic representativeness of the TSX. So this is the entire TSX with and without amphibians, including amphibians, has brought that overall trend down by 14%. So this tells us we need to keep building the representativeness of the index, and this year we'll be trying to bring in reptiles to expand once again. Okay, so what's next for the index? So we called this a pilot index. We got quite a bit of data. We were reasonably happy with where we got to, but there's still some further key data sets to pursue, both for taxa that we have in the index at the moment and also some additional taxa. And then we want to bring in frog ID and other citizen science data sets as well. See if we can generate some time series out of them to integrate into the index. So we're still chasing data. If you have some, or if you know of data, or you think there's data that we might not have, please do reach out to us. But in the interim, you can jump on our visualiser and look at the amphibian index, the TSX as a whole, and other groups, if you like. And look out for the finalisation of this index, the amphibian index, this year, and hopefully also reptiles coming on board this year too. And I'll finish there just with some acknowledgements for all of the wonderful folks that shared data with us. Thank you.
So I'm not Jeff, I'm not Alan, I am Glenn Newnham and I'm from CSIRO. And I'm presenting today on recent innovations and improvements in the habitat condition assessment system. And while I'm not Geoff or Alan, I am a bit of a fraud because the HCAS system has been developed by many, many people over the last 10 years, and all of them, I would say, know a lot more about HCAS than I do. Some of them are in this room, Peter Lyon, Simon Ferrier, Cassie Malley and Sean Levick. But I'll try and do it justice. So just to I acknowledge all of the current contributors to the system, but particularly Kristen Williams, who's been the science driver behind this system for 10 years. She's put together this slide deck. There are a lot of slides, and I will try to make my way through to the impact part of that story. So, habitat condition within the HCAS system, we define habitat condition as the capacity of an area to support all species originally expected to occur in that sort of ecosystem. So HCAS assumes that places with similar environmental characteristics, things like climate and soils and hydrology, should look similar when viewed using remote sensing, if two sites are in their reference condition. So if one of those sites is in reference condition and one has a degraded condition, then we expect to see a difference in the remote sensing variables that we see. So if any of this sounds a bit familiar, then Matt Gale presented some work, really interesting work yesterday, taking this approach and a slightly different spin on this approach. So just like Matt presented, the HCAS system uses three primary input components: remote sensing variables, so what we're observing at a particular point in time; environmental variables, which are things that describe the climate, soils and hydrology, and that's where the sort of Tern impact story comes from in this case. So we draw on Tern data for those environmental variables. And the third input to the HCAS system is reference sites. So that is, we use multiple lines of evidence to determine if a particular site is in its reference condition, reference ecosystem condition. And currently, using a broad number of data sets, we have around about 1 million points that we estimate are in reference condition across Australia. So Albert van Dijk told me to have 3 points, and my first point is just a bit of background for the HCAS system, the method itself, and then what are the recent improvements, and then how that's being used. So very high level, the method involves creating a reference ecosystem model. So the reference ecosystem model takes environmental variables and tries to predict remote sensing variables based on those. So we have that model. We use that to produce a probability surface, essentially. So that's a probability surface if you're looking at a particular pixel. The location in remote sensing data space of that pixel within the probability surface tells us the probability of a pixel being in its reference condition. The probabilities, essentially, from 0 to 1 are the HCAS score. So how does this work in practice? For a given pixel anywhere in Australia, this is a national system, so we're looking at every pixel across Australia. We look at nearby reference sites. We select those sites. and we model the predicted difference in remote sensing variables between the given location and the reference sites. There's a selection of reference sites then made. So essentially we're taking the predicted, where the predicted remote sensing variables are close to the pixel that we're trying to estimate condition for. So by doing that, what we're actually doing is finding reference sites where the environmental variables are similar to the environmental variables for that pixel. So, so we're essentially benchmarking the pixel against reference sites which would support a similar sort of ecosystem. And then we take, this is, the previous slide was showing a near reference condition. This is what occurs when you have a degraded site. So you have a significant difference in the what you're observing relative to what you think you should observe if it was in its reference state. So again, we sort of benchmark that difference using only those reference sites which are similar to the pixel we're interested in. So recent advances in the HCAS system involve a transition from MODIS data to Landsat data, and that creates all kinds of benefits and all kinds of problems for us, and it's involved a full rewrite of the HCAS code. But this slide just shows the added spatial detail that we're getting in terms of paddock boundaries and windrows. This is an interesting slide showing sites in Western Australia where sparsely vegetated ecosystems, you can still detect mining activity within those because the expectation, essentially we're benchmarking the condition against what we expect in that location. So it's quite sensitive, even though there's not a lot of vegetation there. The purple areas in the middle are just showing degraded condition for those low condition mine sites. It's a time series, so we're actually producing HCAS over a time series from 1990 to 2022, and on the left-hand side, this is a RGB time series for an area north of Perth where there's urban expansion. The red cross corresponds to HCAS values on the right-hand side, and you can see as the urban area expands across the red cross, you get that drop in condition. So we're expecting that area to be vegetated, a healthy forested area, and what we're seeing is that clearing and urban expansion and a drop in the habitat condition from near reference right down to near zero, so complete removal of the ability to support the species that we would expect in that area. So, as I said, probably the biggest change has been that switch recently from MODIS to Landsat. So we've switched in terms of the data that comes out from 250 metres to 90 metres, a billion pixels, a lot more data processing, issues created by the less frequent observations, so cloud cover, and so we've had to introduce a lot of masking and sort of uncertainty analysis just because of those limitations of the data. There's just a description. This is Sean Levick's led the remote sensing component here. So the input data from the remote sensing side is from Geoscience Australia, and through their Digital Earth Australia program, and a selection of variables there. And then the reference sites, there's a whole workflow around the detection of reference sites. Then the code base, this has been one of the most significant improvements, capturing the code base in packages. The core HCAS is within an R package, and you can run that on a single pixel, a single location, on multiple different platforms at any time step you like across Australia, as long as you have the right input variables. And then we have workflows that are managed by a Python package. So that's opened up lots of possibilities around doing simulations and testing new data sets, testing new parameters, and allowed us to do uncertainty quantification. So now when HCAS is released, you get a habitat condition score for every pixel across Australia every year, but you also get an uncertainty associated with that. So the data is released through the CSIRO data access portal, as I said, with those HCAS scores for every year at 90 metre resolution, the uncertainty, the input variables, and derivative products as well, particularly around connectivity. And these are being used in federal government DQ annual reporting. So what's the state and trend of habitat condition in IBRA regions across Australia, and also within the nature repair market in a tool called Planner, and as part of the biodiversity benefit assessment of projects, which I think Pete is going to talk about a little bit about next. He might touch on that. And if you would like more information about HCAS, there's a website. Please reach out. There is the data that's accessible, as well as fact sheets and detailed documents. Thank you.
Hello. I think I might be the first pure, unequivocal bureaucrat to speak at this presentation, and yeah, I've got at least one fan for the idea, and hopefully the rest of you will come along for the journey. I'm going to talk to you about this new nature repair market for Australia, and the science and knowledge underpinning it. But yeah, I'm Peter Lyon. In fact, I'm going to take a letter off both. I'm Pete Lyon. And I'm from Canberra, Department of Climate Change, Energy, Environment and Water. And I'm in the Nature Finance and Markets Division. Newly arrived there, you can probably tell. I'm talking today on behalf of a whole bunch of people who actually prepared a lot of this work that I'm talking about. So yeah, there's a good follow-on too from Glenn's. Firstly, I'd just like to pay respect and acknowledge the Turrbal and Jagera people on whose land we're speaking. So, where have I gone? There. The nature repair market. Yeah, it's a new thing. It's the a world first, legislated, voluntary biodiversity market. And in this presentation, I'm going to provide a high-level overview of it, but also describe some of the models and tools that the department has been developing with CSIRO and others to support how the market rolls out. And I'll also look to highlight the importance of Tern capabilities in underpinning all of this. Yeah, the Act came into effect in December 2023 with, and that really kind of brought the market into effect. And it establishes this world-first framework. It provides for biodiversity certificates to be made for projects, and these certificates can be purchased and transferred, claimed, and used and publicly tracked. And the market will be open to landholders with eligibility for projects across land, inland water, coast and marine environments. The market will also promote inclusion of First Nations communities in market activities, including through respectful and consent-based sharing and use of Indigenous knowledge. So since the Act passed, the department's been working, as I said, with other organisations, a range of them, but particularly with the Clean Energy Regulator to ensure that they're set up with the capacity to administer the nature repair market as it comes into effect. It's now open and it's accepting applications under a first method. I'll talk a bit about what methods are later, under a method for replanting native forest and woodland. So this slide shows that there's a bunch of different stakeholders that we have to take into account, I suppose, with making sure that the market operates as something that has high trust and a high perception of integrity. On the supply side, we have landholders who may be interested in participating in the market, and they'll require reliable, accessible and locally relevant information in order to participate. On the demand side, you've got buyers that need information that makes clear how different projects on offer or certificates that might be on offer can be compared. And they need to be ensured that that's evidence-based and consistent with international frameworks. And for the Clean Energy Regulator as well, they'll need to verify that project applications and reports are adequate for those projects to be registered and then for later issuance of certificates. So here's a bit of the, I guess, the legislative framework or different instruments that are in the legislation and then subsidiary instruments. But as well, in this slide, we show some of the way that the knowledge and evidence is being brought to bear. So right at the top, we have this thing called a biodiversity assessment instrument, and it is something you can look up in the legislative, Australian government kind of pages. And it sets out an overarching, transparent and evidence-based standard for how methods should approach the assessment of biodiversity and project outcomes. Now, methods or methodology determinations are similar in concept to those that are used in the carbon market, if people are familiar with that. And they set out requirements for eligible projects, including how biodiversity will be assessed to reflect the specific benefits delivered by a project. So underpinning all of that is this ecological knowledge system. The ecological knowledge system includes things like the HCAS that Glenn's just talked about, but it's a much bigger suite of things. It's got a lot about state and transition models that you would have heard Suzanne Prober talking about yesterday, and Ellen and Peter, and I think there's a variety. We've probably heard a bit about this ecological knowledge system and state and transition models, bringing all of that data and information together to have something that can be combined with site-level information to generate a rigorous view of what's going on at a project. And so it helps market participants develop projects that meet the requirements of the biodiversity assessment instrument, the methods, and then these underpinning biodiversity integrity standards which are provided for in the overarching legislation. So a lot of this is leading towards how do we make sure this thing rolls up as a really high trust, high integrity market for biodiversity. We've never had one of these before, and I'm going off the script here a bit. I was a bit worried this is going to happen, but in my experience, having worked for decades inside the department, we've always just got by without we're just thinking about governments investing in things. But now we're thinking about how do we enable a market where the private sector can really invest with high trust. So our role is to provide that sort of platform that allows that to happen. This is a bit more about the operational flow of information. And you can see the underpinning role of the ecological knowledge system is there again. It comprises these state and transition models, as I've said, and then spatial data sets are combined with that into this thing we're calling the National Biodiversity Assessment System. And there's arrows going in and out of that because that also takes in that really important site level or project level information about what's going on, but it's at that level that we articulate states and of ecosystem types and states. All of that is done, but is also brought into a space where we can quantify change in numbers that can be used in this tool, and then it leads all into this thing called Planner, the Planner tool, with someone sitting there at their desk with the computer. Planner was mentioned yesterday. I've got 1 minute to go. Oh dear, but we did hear that this talked about quickly yesterday, but Planner enables people to access this information on their desktop, and you can do it now if you Google that name, Planner, and have a bit of a play with how it works, and you can see different projects get different scores. A little bit more about Planner. I won't go, but you'll see that slide matches what Glenn talked about before, so you'll see the links. And there's some red circles there to show some really important Tern capabilities. See you there, Beryl. I'm going to make sure it's really so much that we talk about in this room is going to be able to be taken into this kind of framework into the future. So it's, Tern capability is absolutely important here. I won't go into the detail of how the ecological, the NBAS works, but essentially it's quantifying that benefit at a site level. Look, a lot of this stuff has been really well published and documented, and it's on CSIRO's data access portal. There's a technical report which you can look at. It's really worth having a look at how these numbers come out, such that you can actually say this project, 100 hectares here, doesn't get you the same biodiversity benefit as this project over here, and we have a rigorous basis for being able to say how that would be done. It's consistent nationally, it's cool, but it's got a long way to go. As we can see here, continuous improvement is part of the thing, and of course accessibility and transparency of information, as I've talked about. A lot of this stuff is available, and this leads to supporting the integrity of the market. So I'll leave it there. Thank you very much.
Good afternoon, everybody. So I'm Vicki, and I'm just going to give you... Yesterday, Madeline Godillard introduced the AusSet network. So Beryl decided to breach into our coastal ecosystem areas, and I'm just going to give you a rundown of a case study of why this is so important that you need to take it on, and we need to continue to monitor it, and it should be included into a one big system in Tern. So the fate of lower elevation mangroves. So I'm going to talk about what happened here and why it's important to measure elevation in mangroves. This is actually a study that I did for my PhD that has been published last year. So I'm going to start with knowing that you guys are mostly data scientists, and I'm going to say, why do we care about our coastal wetlands and why should Tern take on this big space? So coastal protection, without these storms in the last few days, you'd be wiping out more of your beaches than what are already wiped out. Coastal erosion control, habitat provisions, water quality, all these sediment plumes that come down the rivers, most of our mangroves just contain that within their soils. And we don't mention carbon sequestration, so 4 times the amount of rainforests are held underneath mangrove soils. The big one, as you know, is habitats. 6 million fisheries globally. A new study was rolled, and they're just such important ecosystems. For something like 90% of terrestrial animals actually use a mangrove and coastal ecosystem at some stage in their life. But the big thing that I want to talk about is sea level rise. So obviously we all know sea level rise is rising ever so smallly, but it's impacting the coastal wetlands. And our mangroves and coastal wetlands are able to adapt to these changes and increase their soils at the same rates, we think. But there could be issues, obviously. So how does it happen? So just in a nutshell, our elevation tables, we get a hammer drill and we hammer in some stainless steel rods into the bedrock. So here in Moreton Bay, it's about 15 metres deep. So we hammer in these, and then we attach a little receiver to the top, and then that's all you see in the wetland. And then we come along, attach our little measuring arm, and these pins vertically and horizontally, they're leveled. So each pin drops to the same point in space every time you come back to measure. So you're measuring this fine scale, millimetre changes, at the same point in time every time you come back and measure it. We also couple it with this marker horizon, so we lay out some feldspar, and then you can measure the amount of sediment accretion that's accumulating on top. So this is all very, very important, and obviously it's a mangrove ecosystem, coastals, so there's lots and lots of processes that are happening to make all of these changes within this bedrock of elevation change that we're measuring. Most importantly, from years and years of study, they know that sediment trapping, binding, root production, these are the really important drivers of change. However, sediment accretion and erosion, compaction, so you've got these soggy wetland soils. We can't put bags on the floor. We're all covered in mud. It just compacts the soils down so ever much. So there's lots and lots of little drivers, and we want to figure out what's going on. So this case study comes from Point Halloran Conservation Reserve. It's a really, Brisbane, as you know, down the river. So we're just going south here. It's a really, really special place because it's got a really old mangrove forest, and then it's got this, it's traditional. It's got a mangrove forest, and it's got these really thick rhizophoras, and then it's got these scrubby little mangroves at the back. Then it's got a salt marsh, a cyanobacteria, and it's got supertidal at the back. So it's got everything you want in one small little area. So we've got surface elevation tables, obviously, in here. Now, the big important thing that people love to know is I've been measuring surface elevation in this wetland for 18 years. Now, these data sets then get hidden because I've got it and none of you guys have got it and we haven't given it anywhere. So that's, we're holding on to, and this isn't just me, there's other national people measuring these things, and as well, they've got their 20-year data set and they're holding on to it too. So the important things to take from this is surface accretion is the accumulation of sediment on top of the surface. It's coming in at about 7 mils a year. But what happens in the surface elevation, and what I'm talking about is this 15-metre elevation change, is that it's compacting down, and we're only at 1.7 mils a year. But sea level rise is at 5.3 in the bay. So are they keeping up with sea level rise? Necessarily not. You might see a bit of a dip in the top one up there in the surface elevation change. You'll see a bit of a dip, and this is the story that I've got to say. March 2021, there was a severe rainfall week. 230 mils of rainfall came down at a proper creek in a week and 130 in a day. I went out spontaneously to have a look at the sites, and this super large tree had fallen. So that's like the roots have ripped out from underneath it, and that, as I said, root growth is really important. This has probably caused that decline. So I was out there a few days later measuring the surface elevation along our lines to see what was happening. But it didn't just happen once. March 2022, we had the floods, and I got more trees that fell down in the same area. I'm only talking 100 metres. More trees fell down. So there was 2 dips. So this is a 10-year data set here. You can see the elevation was slowly going up. We have replicates of 3, obviously, in all of our systems. But so they all were, elevation was rising. We had an instant dip. And what I'm looking at is a 25 mil dip in elevation. And if you're looking at, they're only scaling up at 2 mils a year, 10 years down already. I'll zoom into that one a bit more. So that's 5 years. We had elevation was going up and we had a dip. This looked like it was going up, so I was out there measuring this every two weeks to see what was going on and whether it would rise up. And then we had the next flood and it dropped again. So it is coming back. I have measured this again at the end of last year and it is coming back again. But we wanted to know why. So obviously over time, the tree decomposes. So decomposition rates occur, which then puts more weight onto the ground. And we measure root growth. Obviously, it's really important. But first, I better tell you about roots. So mangrove roots, we can measure these by digging holes and pulling them out and having a look and seeing how deep they are. Originally, in literature, you'll find that mangrove roots only go to 30 centimetres. This is false because we've now done things like this and we've measured it. This is still anecdotally. There's a new paper out that says that mangrove roots go to 2 metres. Again, this is brand new studies. But they're really fine roots, and lots of them. And they like to dig in because they're really anaerobic soils. There's no oxygen down there. So that's why they didn't think they went further. But they're really squishy, they're air-filled, they're porous. So I need to tell you that because they look a bit like this, and then suddenly you're going to put extra weight and extra mud on, and that fall, and they're all just going to squish. Like they've just lost anything. They're not alive anymore, so they're just decomposing down. So you've lost all of that in there. And basically, I should have done some extra root things at the time, but the one from the right-hand side here is what the root bags look like from around the bark of the tree that fell down. There's no of these little fine roots, the little tiny mangrove fine roots, none of it. So there's no root growth at all. It's all died, and it's just completely subsided down. And this is the type of small roots I'm talking about, really tiny fine roots. And the elevation, and so basically it was all came down to a real, trees are dying and the elevation is falling. Is this going to hinder long-term survival to sea level rise? Possibly. Long measurements are taken. We need to know more. So this area could turn into a bird area. People love birds. So the mangroves might retreat landward. Where there's room here. So they could retreat landward, enable more area for birds. This study site is very low, so it is 0.2 AHD, which is very, very low in the elevation, so it possibly is too low for recruitment. The mangrove could re-sprout. This is very well known in the literature, that fallen tree might actually fall down, and then halfway through the stem, it will just start growing again. A new study that we're looking at, Rhizophora also might colonise the area. So it's another species that's coming down further south because it's more temperature tolerance. And then that species, which has a faster growth rate, it's easier to colonise an area, that might come into the area as well. So this is continuously monitoring areas. We have sites, 300 sites all around Australia, and this needs to be picked up by Tern. Thank you.
Hello everyone. For those of you who don't know me, my name is Sally O'Neill and I work for Tern Ecosystem Surveillance at the University of Adelaide. My boss is here, Ben Sparrow. He's been mentioned a lot today and yesterday. And in fact, this entire project that I'm speaking about today has come up in numerous sessions today already. Jun went through the vocabulary and definitions earlier today. It popped up a few times yesterday. Zach, for example, in the wild orb stuff, we collect metadata for camera trapping stuff, which then magically gets sent to wild orbs to look at the photos. This is the current project team on the authors, but just acknowledging that it is a massive project, and I feel like half of Tern has been involved. From Mindy up in the back, her beautiful logo and the images that she's created for us. Jaden posting constant YouTube videos. Nico's been involved in creating a lot of those video contents. So a big thank you to the wider team. Those last three authors, other than Ben, are actually from the federal government. They work for the Department of Climate Change, Energy, the Environment and Water, and they've been heavily invested in this project as well. I'm really speaking on behalf of Ashley Leedman because this project is about his vision for improving the data collected for federal government natural resource management project investments. So a bit of a recap on what Tern Surveillance does, and then I'll launch into what this new project's about. If this is sounding slightly familiar to you already, I also did present on this project in the very first instances at the Tern Science Symposium 2 years ago. It just didn't have a name back then. So we are now talking about scientifically robust data from Tern's 1,000 plot network. You've seen the map many times. I'm going to show it one more time in just a second. Standardised survey methods implemented by Tern's own personnel. If you saw me on the phone last night in the museum, I was talking to both of our field teams that were currently in the Pilbara. So it's our own team on the ground collecting data in a way that Tern developed those methods in the standard ways. And then Donna yesterday actually did speak about our Tern soil and herbarium collection at the Way campus yesterday as well. And then you also know about Tern site instrument stuff. This project, however, is all of that, but rather than Tern personnel collecting the data, we have NRM regions, so the regional delivery partners that have been funded and contracted from DQ to implement these projects. This is the lovely Lyon from Central West Local Land Services in New South Wales. So these are the guys implementing what this project's about. There's that map again, just highlighting that Tern protocols being implemented by Tern personnel have created this 1,000 plot network. This project, I don't have plot locations just yet. Look forward to presenting those in 2 years' time. But these are the NRM regions around Australia that have regional delivery partners implementing these projects. So you can imagine that all of these projects are now creating new plots, extending our plot network across these regions. We have a little bit of work to do. The lighter green ones have projects that are using our methods. They just haven't done the on-ground surveys yet. We're looking forward to getting some spring survey data coming in shortly. And the grey areas are still a work in progress on getting them to adopt the Tern EMSA methods. We do have some progress being made. For example, the Northern Territory, that is just one NRM region, does have some Indigenous ranger groups looking at doing projects that could very well be using this methodology. So we look forward to getting them on board shortly. This is an impact story. I could have presented in the methodology section or the data, but here we are talking about the impact. So as I said, Ashley's vision was all about improving the data collected for the NRM regional delivery partners, getting them to collect scientifically robust data that you should be all familiar with, the way that Tern collects things. And being able to measure federal government investments, for example, through the Natural Heritage Trust. So what does the federal government, the Australian government, what do they get for their money that they're investing through these projects? In the past, they used to be able to say, we planted so many trees, we implemented so many kilometres worth of fencing, removed certain numbers of feral animals, but really what does that mean in terms of the environment and how is the biodiversity improving over time? How can we turn that language around? So this is why this project came about, is to turn around the way that data is being collected so we can understand the benefits of the project, of the projects that are being funded. We've got a picture there of the long-term monitoring plan. It all comes back to that. And some other projects that are through the Saving Native Species projects as well. So they're tied back to the Threatened Species Action Plan. Here's Mindy's lovely logo. EMSA was born in the John Gordon building. We had a little powwow session to go, we can't keep calling this the Tern method all the time. As much as we love the fact that Tern's getting promoted, it was time to give it its own name, its own identity. So EMSA was born and we got Mindy to do a lovely logo. EMSA is 24 standardised survey modules. By module, I mean a topic. Within that topic, there's many, many environmental attributes that we've clumped together, and I'll go through a few of these in a second. A field data collection app called Monitor. Andrew Totmakov's presentation yesterday covered a lot of that. The instruction manual, we're also about training and support, the standardised vocabularies that John talked about earlier today. Just as an example, poor John and the team, and Aran, who I know was online earlier, were thrown a massive vocabulary and definition set to work on. This project launched heavily into fauna protocols as well. We've had many, many Zoom discussions on why we're including, why it's important to measure the forearm length, so the tibia of a bat, and why it's important to talk about amplexus in frogs, so the little grippy pads that the males produce on their fingers, or toes, whatever you call them, during mating season. So lots of fun discussions and the vocabularies that were associated with that. Through this project, instead of coming to the Tern data delivery portal, the information is actually going to a newly developing biodiversity data repository, so the federal government itself, who will be then responsible for controlling that data, but also have committed to making it available with a little bit of control of what private land information and that sort of stuff is released, again with threatened species locations and stuff, the ability to withhold some information. But if you're a modeller, stay tuned because there's a lot more information coming your way to support your work. So EMSA is about establishing the best practice monitoring protocols targeted to project-specific needs. So the regional delivery partners get to design their monitoring program based on what their project is all about. They get to pick and choose which modules to use. We're about improving the understanding and measurement of and the effectiveness of natural resource management and restoration actions, strengthening the evidence used to assess the achievements of those outcomes, and facilitating better access to and reuse of ecological survey data for adaptive management, conservation actions, research and policy. These are the core modules that you should be familiar with. That's what the Tern ecosystem surveillance team, with those 1,000 plots, have implemented essentially what all these modules are. So we're establishing a plot, describing a plot, doing the soils work, photo points, floristics, plant tissue vouchering, cover and basal area. Donna talked a lot about those ones yesterday. But and then for this project, we had to build a whole lot more modules. So we are covering off all of those ones I mentioned before, the Tern core ones, plus now we're launching into a lot of fauna work, as well as invertebrates, and some stuff that's done off-plot as well. So you can imagine establishing transects, looking for feral goats, feral deer, and multiple other species. We're also talking about the management interventions that are being implemented as part of these restoration projects, pest fauna animal control activities, and all those sorts of things. Just as an illustration, the vertebrate fauna module is a big one. We're doing anything from a 20-minute bird survey in that module. We're putting out acoustic devices and ultrasonic devices to collect the metadata from what sampling is being conducted. We're doing trapping through pitfalls and elliot and cage traps and a few other things. And then we also have the other modules that are also relevant, so fauna ground counts. We're doing vantage point surveys, which you could be recording from any type of species, a lot of pest fauna species, as well as bird surveys. So there's a whole variety of information being collected. The modules themselves, if you're a lecturer in the teaching environment, these are a great resource. Each document has a rationale for why the ecological variables are important, and they identify the key literature, what standards already existed and why we chose the methods that we did. So they're a great literature review resource, and they really justify why we went with the measures and the methods that we chose. And the documents are really good if you're an on-ground person and you need a cheat sheet to understand how long does this method take me, what sort of staff what skills my staff will need, and how long I can expect to take them. If you're a consultant or a regional delivery partner, having that information at hand is really useful when you're understanding the budget requirements and how to plan your monitoring program. The documents themselves provide a step-by-step procedure and instructional information. It's really fail-proof, and again, paired up with the app itself, you really can't go wrong. It's confine drop list instructions. You can't, for example, say that a tree was 180 metres tall. We know that that wasn't real, so it confines you to little limitations like that throughout the whole thing. Yes. I won't go too much into Monitor, which is the name of the app. Angie covered a lot of that yesterday. Oh, 1 minute. This is what happens when you don't practice. What we're doing with this project now, it's been up and implemented for quite a few months now. We do have a lot of plots happening. We do have an entire help desk with an ecologist and technical team on board, ready to take questions. We do receive calls from people in the field. I'm doing this wrong. Why isn't this happening? How do I measure this? Can you please run me through it again? We've got people doing that all the time. And now we're doing an on-ground training program. A couple of weeks ago, we did our first one in Dubbo. We're about to go to 6 other locations throughout the end of the year, which is a 3 to 4 day training program, really demonstrating and holding people's hands on how to do these surveys. Strengthening the impact of Tern and what this project is about next. So we really want to continue to train and upskill the regional communities on how to do their own surveys, sustain the scientific rigour of the data that's being collected, and really empower these people to be skilled, collecting great data and feeling like they're being supported. We're just not ditching a method at them and saying good luck with that, but we're really holding their hands and stepping them through it. It is all about enabling the good quality data back to the queue for them to understand where those investments and what a great job they're being done. We are all about cementing the role of Tern in delivering research infrastructure to support environmental policy and investment and decision making. Ta-da!
So, my name is Trevithick, and I'm with the Queensland Government what are we called now? Earth Observation Group. And today I'm going to be talking about how we've been harnessing Tern infrastructure for about the last 10 years to deliver some of our more important open data sets. With a specific emphasis on the Veg Machine app, which is a very lightweight app that directly accesses data that's on the UQ Tern node. It says this is out of date, actually. We just changed our name last week. So prior to being Earth Observation, we were Remote Sensing Sciences group. Despite the name, we are one of the oldest remote sensing groups in Australia, established in about 1995 with the SLATS tree clearing framework. But we've expanded from that, and now we monitor all sorts of different vegetation and produce all sorts of different products for vegetation monitoring. We also have partnerships. There are two primary partnerships that are of relevance for this project. The Joint Remote Sensing Research Program, who provide the compute for which we run Veg Machine, and also Tern, which we have been involved with from inception, really. We produce a lot of products. The ones that are relevant for this are these large statewide vegetation monitoring data sets. So they're really quite big data sets. They're statewide. They're 1 gigabyte to 5 gigabytes in size. They're all in raster format. And they're frequently updated. That's the USA, that's not, that's not us, but it's the only stack I could find of images that look like that. So we update them once a month or seasonally, depending on the product. And the key point of this slide is that, these are big data sets. In 2012, the Queensland government introduced an open data policy. But unfortunately, for a lot of the government data sets, it was possible to deliver them, but unfortunately, the Queensland government had no way of delivering these really, really large statewide mosaics. So we had to rely on Tern, and at that time, we were really a key member of Tern. We were active technically, building the UQ node up with infrastructure, and we were provided with some really basic. This is not the Tern you know of today. This is not this polished infrastructure. It really was the Wild West back then. And all we had was, we had a file server, we had a GeoServer for delivering WMS layers, we had a wiki, we just did all our metadata on wikis, and we had an FTP before we knew that the FTP was, not safe, I guess. And so what we did was really, we just pushed all our files across, we wrote some metadata, and we pushed it out there. And so with that, we were able to tick our open data policy box to say that we had successfully delivered these data sets. However, even though we had managed to do that, these were really big data sets. If you didn't want to do a statewide analysis of the time series data, you would have to download all of these data sets and then have specialised skill to just extract small areas. And most people didn't have that, and certainly the key people we were trying to reach didn't necessarily have those skills. And that's where Veg Machine comes in. So Veg Machine is actually a CSIRO product. It's been around for a while. It was first created in 2002. It was a really simple product. You can see down at the bottom, it just had a map, which you could draw a polygon around, and then that would give you a time series trace of your data. And it was used as a grazing extension tool. It was a PC product, so you had to load up all your data sets and actually lug a laptop out to the site to talk to a grazier. In about 2012 to 14, somewhere around that, the Queensland DPI approached us and asked us to build an online version of Veg Machine. Now, to build a fast time series data extraction drill that can produce these kind of time series, you had to have asynchronous access to the data. We were still very active in Tern at the time, so this was prior to things like cloud-optimised geotiffs and data cubes. It was really early on in the piece. So what we did was something really cheeky, and we went in and we built all of these time-enabled WMS layers, and we used those. So you would just extract from a WMS, which is completely off-label use of a GeoServer or a WMS server. But it worked really well, it was very fast, and there was a bit of buzz around it for a while, and people really sort of were excited about it. And it was probably one of the first time series drills of this type, in Australia. But there were issues, early days of Tern was extremely unstable. Things used to go down in Tern all the time. The storage went down, the GeoServer went down, and the only way you could fix it was to go in manually and reboot it. And we lost a lot of possible users during that time because I think people got a little bit tired and a little bit fed up. Additionally, the way we were doing that with the WMS interface, it really restricted what data we could supply. So, 3 minutes, wow, oh, that's really quick. So there were issues, yeah. And we got to the point where we were ready to move away from Tern as a way of supplying our data. Queensland Government had introduced things like an Azure framework, but to move to an Azure framework, we would have had to really completely rewritten our code base. Fortunately for us, in the last 18 months, I'd say, and I think the boys over at the UQ Node have talked about this in earlier sessions, they've done a lot of work stabilising the data and introducing these cloud-optimised geotiffs that enable us to just extract portions of the raster data sets. So with that, it's faster, scalable, more reliable data access. So with that, we rewrote our application programming interface. It's now a Python-based, I'll just race through this because it's quick. Now Python-based asynchronous API. It directly accesses the cogs. It's still quick, but it's incredibly stable now as opposed to the old system. Okay. This is a shameless plug. So in addition to the rewriting the back end of the tool, we've also completely overdone the front-end interface for VegMachine. So I've introduced new charting, advanced charts. We've developed it as a mobile-first web design, so you can use it on a mobile application. We've introduced some field applications, so there's a GPS logger, so you can just analyse things in the field with a simple click of a button. And we'll continue to implement more tools and products that are relevant to our user base. So we have a fairly small user base, mostly of extension officers, regional groups, those kind of small people that are working in that sort of space in Queensland. And just finally, because I think I'm running out of time, I just wanted to talk about the impact, because this is an impact story. So, and it is a bit of a shout out to Tern, because without Tern, we would never, VegMachine would not exist, and it would certainly not exist in this format. So the impact is, even though it's only a small, small tool, we have over 300 regular users from all states and territories, so not just in Queensland. It's been referenced in 30 peer-reviewed publications, and if you take out the peer review, there's a bunch more people that use it. And it's been identified as a key source of vegetation time series data by numerous government agencies. So even for a small tool, it's actually had a fair bit of impact. And we have Tern to thank for that. So that's why the shout out I wanted to give them. Also, this graph, I just wanted to show you, this is our annual returning users. And you can see around about a year ago, that's when Tern managed to stabilise their data structure. And you can see there's been a bit of a turnaround there. And I'm really hopeful that, if that continues up, and a girl can hope, that eventually we might have a really broad impact. And I've got 1 minute. Well, don't need it. You'll have it? Okay. Okay, thanks.
All right, hi everybody. My name is Samantha and I'm a research scientist at CSIRO. And I know I'm really lucky today because I have the coveted time slot of the last speaker at the end of a long session between lunch and afternoon tea. I know everyone's super jealous. It's typically when we're all most alert. So just in case, for whatever reason, people are feeling a little bit tired, last night when I should have been relaxing at the bar with some friends, instead I got super nerdy and I wrote a haiku that summarizes this up. So if for any reason you get a little bit tired, just retain these next 17 syllables and you will get the general idea. So here we go. HCAT needs your help. You are an eco-expert. Please give assessments. Okay. I was seriously peer pressured into doing that. Do you know what? I saw a couple of people at the top silently counting my numbers. That was the most stressful part. I'm pressing the green one. Oh, there's two. Now I get why that was confusing. All right. All right, so if that made no sense, hopefully the next probably 10 minutes I've got left will clear some things up. So HCAT stands for the Habitat Condition Assessment Tool. And this is a website that was built in partnership between DECU, CSIRO, and the Atlas of Living Australia. And its purpose is to create a place where ecological experts like yourself can log in and report on the ecosystem condition of sites you are familiar with. The ultimate goal here is to create a publicly accessible library of condition assessments for the country that can be used to support research, monitoring, and reporting. Now, a few of you have probably heard of HCAT before because there was a pilot launch in 2018 with a select group of participants, but since then we've been working on a lot of improvements, and we're now ready for a relaunch nationally, and that's why I'm here to convince you to please give assessments. So before we get stuck into all that, I would like to begin by acknowledging the Bindal and Woolgaroo Kabah people, who are the traditional owners of the lands that I live and work on in Townsville, and I pay my respects to their elders past and present. So let's back up a little bit and talk about what HCAT actually is and why it was created. So as absolutely no one who is affiliated with Tern needs to be told, reliable on-ground data is essential for managing our native ecosystems. And we know ecosystem practitioners in this country possess invaluable knowledge on habitat condition. Unfortunately, accessing that knowledge is not always easy. It's often inaccessible, scattered across institutions, or it may not be recorded. And as was beautifully demonstrated by some of the talks yesterday, there isn't really a universal approach to defining or measuring condition, so that can make national integration quite challenging. So we identify a need for a consistent and reliable way to both collect condition assessments, but also calibrate them to make them comparable. And this is why the HCAT was created, to help with this need. HCAT, which is hosted by the Atlas of Living Australia's BioCollect information system, not only provides a place for you to share what you know about ecosystem condition for different locations, but it also calibrates those assessments among different participants to make them more comparable. And we achieve this through 4 steps. The first is, because it's part of the ALA, you log into HCAT using an ALA account. The second thing that we need participants to do is the image assessment task. And this is what allows us to calibrate different site condition assessments that are provided. During this task, you will be asked to nominate your areas of expertise, like the major vegetation groups with which you are most familiar. Based on those selections, you will be provided with a very small selection of images that you will look at, and it will be of those habitats that you are more familiar with. And we're going to ask that you score the condition of the habitats that are in those images between 0 and 1. 0 being the lowest possible score and 1 being the highest. And I'll provide a little more information on what a 0 and 1 is in just a minute. Now, this is not a test. You can't fail your assessment of the image. The idea here is that other experts with similar areas of expertise will score the same images. And this will give us a sense of who amongst us tends to score higher or lower on a consistent basis. And from this, we derive a correction factor that we later use to calibrate the site condition assessments. And don't feel bad, I am constantly way too optimistic, apparently, so my scores always get brought back down. So what I'll do now is just show you a little demo of how the site condition assessment process works. When you go to the website and you click on the button to open the form, your name and the day's date will automatically appear. But don't worry, if you prefer for your assessments to not have your name associated with them publicly, there is an option to be anonymous as well. The first thing we need to know is when the assessment is applicable for, so we need you to provide a date as accurately as possible. However, we appreciate that you may not remember the exact day to which you feel your assessment applies, so you can tell us your degree of accuracy on that date, whether it applies to the day, the month, or the year. And in this case, the beta tester that provided this example put the month of February. You can also add an end date if it applies over a broader period of time. Once we know when, we need to know where the site is, of course, and there's a couple different ways you can do this. The first is using a mapping interface by zooming in to the location and drawing a polygon around that area. Now, I'm going to draw a fairly simple rectangle, but you can free draw more complex shapes. And at this point, I'll mention, again, this is an example, so please don't take the condition numbers that you see here too much to heart. And that will then save the polygon. Alternatively, you can also enter the coordinates manually if you have a square-shaped site. So I don't know, maybe your Tern ecosystem surveillance, you've got a couple plots you've been to, you could enter the coordinates for that and put in the area and the units that it's measured in. You can also provide us with photos of the site if you happen to have them, which can be really valuable context, but you obviously need to have permissions to supply us with those photos. Once we know when and where the site is, we need to know what you think its overall ecosystem condition is. And so this is when you put in that score between 0 and 1. And again, more on how we define that score in a minute. Importantly, the score should be homogeneous for the whole site. It is not an average score for the site. In addition to the overall condition, we ask that you also score the condition of 4 ecosystem characteristics, such as physical properties and ecosystem function. This just gives us a little bit more detail about what is going on at the site, in your opinion. And then last but not least, if your ecosystem condition score is less than 1, we also provide you with an opportunity to tell us why. So this is where you can tell us about the anthropogenic drivers that may be negatively influencing the condition at the site. So we give you a list of 13 common drivers, and we ask that you score the impact of those drivers, again, between 0 and 1. But in this case, 0 means that the driver is not present, it's effectively absent, it's not having an impact, whereas a 1 would be the highest possible impact that that driver can have at that site. So once you've gone through and filled that in for each driver, there's also an opportunity to put any additional comments or context, which has proven very useful in the past. Sometimes people tell us this was actually a part of a survey or it wasn't. It's really useful. Then you can submit the record, it saves, and you can view and edit your record at any time. Okay, so a little bit more briefly on, now that we know how the website works, what I mean when I'm talking about condition, because again, yesterday there were quite a few different definitions. So within HCAT, we express condition, again, as a value between 1 and 0. 1 is defined as a site with the highest ecosystem integrity, as might have existed prior to European colonization. So a pretty firm benchmark. On the other end, a 0 is a site where the ecosystem has been completely transformed and all native species have been removed. In terms of how you go about deriving your score should be intuitive, internally consistent, and in alignment with those definitions. Now, by intuitive, what we mean is that you decide, as the experts, which ecosystem attributes matter, sorry, that should say attributes, not characteristics, and how to weight and combine them when getting a score. Now, we justify this approach because when you think about how we go about deriving a condition score when we have empirical data, we're making a lot of choices when we get those measurements. We're deciding which variables to measure, how to measure them, and ultimately how to combine them to get a single overall score. So HCAT asserts that all the subjectivity and noise that's involved in that process when we have empirical data is consistent with the subjectivity and noise with an expert simply intuiting a score. So before I wrap up, I wanted to, because I'm in the impact section, talk about what the impact is for some of the pilot data and what we hope the ongoing impact for this work will be if you choose to contribute. So I already mentioned the major goal for us is to create this national library of sites for people to use. And certainly yesterday I saw a lot of examples where this kind of data would come in handy. But most immediately, the data collected through HCAT will be used to help the habitat condition assessment system and its outputs. Glenn showed very briefly a workflow of how reference sites are used in HCAS. Well, HCAT directly contributes reference sites as well as modified sites to validate the outputs. And indirectly, this has a number of other, I think, pretty big impacts as well, because HCAS, as we saw, is quite a significant contributor to the nature repair market. So we know that if we can get better, local and regional reference site data, we can have much improved biodiversity forecasting for all of these other applications. And we have seen that in HCAS when we've had local data, those regional estimates vastly improve. So I'm going to bring this back to my haiku, which is give assessments, or please give assessments. I put a please in. The original draft didn't have please, but I'm Canadian, and it felt weird being that aggressive without, saying please. And now for some reason I feel like I need to apologize. It's just part of who I am. But yeah, so we really do need your help. This doesn't work if experts like yourselves don't contribute what you know. So we're calling on all experts to start contributing to the HCAT. And this is day one. This is the launch. The website has been up and running for a couple days now, so you're getting in on the ground floor. And as an added incentive, if you contribute before April, you will be eligible for authorship on a data report that we're going to be submitting to a scientific journal. But for privacy reasons, you do need to opt into that process, so make sure you follow the instructions on the website to let us know you do want to be an author. Okay, that is everything I wanted to say. That is the website. Like I said, if you've got weekend plans, cancel them, because this is just, this is what I would want to be doing for sure after a long conference, is going home and doing this. Big thanks to DeQ, of course, the HCAT team from 2018. Tern has been a huge part of this because they supplied most of the images that we used for the website, and the countless people who tested this website before it launched. Thank you.
Okay, if all the speakers to the center. Beautiful. So I might start from the very first question. This is for Geoff and the TFX.
Yep.
So if we are seeing major declines for the non-citrate affected species, when do we consider expanding the index to non-threatened species? Could this raise the alarm before, and then it was cut?
Yeah, that's a really good question. So the TFX is the first time that we've sought to integrate data for non-threatened species. So every time we collected a data set for a threatened species, if there was associated data for a non-threatened species, we collected that as well. So we do have that data there, and we do have this long-term ambition to broaden the TSX out to be a general biodiversity index, and the TSX would essentially be a sub-index of that broader biodiversity index. So yeah, that is in our expansion plans.
Okay, follow-up to that one is, the TSX shows really how important it is to have trend data to support conservation management decisions. And then the question is, what is the biggest obstacle to unveil trends for more taxa? Is lack of data, it is funding, both, more of that?
Both of those things. I think one of the key challenges for the TSX is the amount of time and effort it takes to get these data. They're really distributed widely amongst individuals, academics, government departments, and so there's a huge program every year of trying to get hold of this data. And then there is some reticence to share data with us, and some of that is very legitimate. You know, people have got concerns around data security and coordinates being shared, etc. And we have protocols in place to ensure that doesn't occur. But yeah, so there's a lot of time and effort in convincing folks that they can share data with us, it will be secure, and that we will respect it when it's shared with us.
Perfect, thank you. Chad, this is a question for you. It says you have done eddy covariance data, but is there another type of data for which you could do a similar transformation?
Chad's actually left.
Chad left?
Yeah.
No more Chad. Okay. There is one more for Geoff, but I will go around and then come back to you, Geoff. Glenn, do you believe Australia values the benefits of HCAS enough to pay for access to the satellite data? Should that ever be introduced by overseas agencies?
Yeah, depends how much. But I think you've got to think about all of the benefits of satellite data, and HCAS is one example where satellite data is used and it flows on to inform policy decision making, hopefully decisions around projects in the nature repair market. So that, it's just one of hundreds of examples, and without that satellite data, so many of our systems, so much of our knowledge would disappear. So do I think that somebody's prepared to pay for it? Yes, I think so, but it won't be me.
We will find the users. Pete, for you, how much do you need state and territory cooperation or buy-in to succeed at the national level?
Yeah, so the nature repair market is making, I guess, the use of the best that we can bring together around Australia's data and information. And that's always been a job that, traditionally it's been really a lot of the effort of state agencies has been in that area. And so the Commonwealth's job has been to try and pull that together and to make as best sense we can, compilations that have got as much coherence as we can get. And you've heard a bit about that perhaps with the National Vegetation Information System, which is part of what currently is used in the National Biodiversity Assessment System. So there's probably a bunch of different ways, if I thought about it, I could trace back to the capability and the effort that goes into collecting information in the environment that finds its way through various forms into what we now see in these sort of big overarching tools. But yeah, essentially it's really important that we keep that momentum going and we do the things that are required in order to maintain what has been, I think, decades of some success really in bringing stuff together, and it goes back a long way. Some of the data that's getting used is old data, is not necessarily bad data. It's still telling us something about pattern, and so that's really important. So yeah, it's not just state and territories as well. It's non-government organisations and a whole bunch of people leaning into this, and a lot of the capabilities that we're building here, including the biodiversity data repository and things like that, are helping to try and bring that together.
Perfect, thank you. Vicki, you're the next recipient. Vicki, do we measure surface elevation where you can get access, or does that not matter because you can extrapolate what you measure and apply your findings to other areas of the coast?
So it's an interesting one. So we actually measure at randomised points, and obviously we can't have these things everywhere and you can't measure them all the time. But that is the next goal. There's already models being created from our data at each point to then extrapolate to the bigger wetland areas. So yes, it is possible, and it's all through modelling. But the issues with that is to go back to the person that collected it, because they can explain the data to you, because it's not easy to understand.
Okay, there is a follow-up for you. How do you know it was compaction versus an increased erosion rate from an increased flow of water?
Yeah, so what I didn't measure was, I didn't actually include the surface accretion data, but actually we had a big chunk of surface accretion as well, on top of the surface, as well as the compaction. So it's a combination of sediment coming in and compacting the surface down, as well as the root loss.
Okay, thank you, Vicki. Sally, next one. IMSA is driven by DQ and promoted as Australia's standard monitoring protocols. How will IMSA be impacted by the Indigenous standard monitoring protocols being developed through DQ NESP?
Sure. Ultimately, we would love all Indigenous communities doing some monitoring to be using our methods and particularly our app. We would love to be able to modify the app to make it more user-friendly to suit the requirements of some of the programs. A lot of them are doing methods that are in EMSA already, so ground counts, sand track monitoring, camera trapping is massive in Indigenous communities to be able to collect some great data. And we definitely are working with a few. The example in Northern Territory is where there's Great Desert skink projects coming online soon. So I'm negotiating with those groups to work out how we can adapt the methods that we've already got to cater for their needs better.
Perfect, thank you. There is one here, Sally, it says, for Sally and Alison, SPECT, what is the relationship with existing training organizations like UNIS and TAFE? I'm guessing this is about the monitoring protocols.
Yep, thanks, Alison. University of Southern Queensland is already using AMSA. We had an entire field program went out in October, I think, late last year. We had a student messaging us, letting us know all about it. They were doing vertebrate monitoring using our manual, so the PDF document, and our data sheets because they didn't have access to the app. And I think that's the next phase of this program is to work out how we make monitor more readily accessible. At the moment, the data is collected, it goes to the biodiversity repository. How can we make it so that it can be used for student projects and stuff? In terms of the TAFE side of things, just Tuesday just gone, we actually had 23 TAFE educators come out and visit the Tern collection to run through, and Ellen definitely covered off on how AMSA can be incorporated into TAFE learning programs already. So we're covering it all.
Excellent. Yeah. Okay, beautiful to hear that. Sam, for you, do you partner with universities for students to contribute to HCAS as part of their coursework? You know, many times we have field works, we have many activities at under and postgrad levels. So do you partner with universities?
Okay, so it's not, so no, we haven't established any direct partnerships, but this is quite literally day one of where I'm taking this show on the road. So I'm going to be bouncing around a lot at different conferences, workshops that will be centered around universities and different programs with the nature repair market, the EKS, HCAS. So I am open to that and I'm keen for that, and that's one of the reasons that I won't be home very much in the next 6 months because I'll be doing a lot of stuff like this.
Okay, and follow-up, what is your expectation in regards to metrics of success for HCAT?
So the pilot study was really interesting because the way that was designed was a very targeted recruitment process. So people were contacted by email rather than what we're doing now. And the big thing that they noticed in the results was the biggest problem that they had in that pilot was it was very hard to register to participate. The image selection process was not automated inside the website, so you had to register your interest with the project manager. They had to confirm that you were participating. You had to tell them what your areas of expertise were. Then they sent you the photos. Then you scored the photo. It was weeks. Okay. So we've now made that process a couple minutes. And what they found was they got, I think, like 80 to 100 people who said they wanted to participate, 40 people who actually followed through on their areas of interest, and 28 people who wound up contributing data. So I think a big measure of success for me is going to be seeing how, if we can get past that huge hurdle from the pilot and just keep people in it. Because it is a much, what will take weeks, you could now do in the whole thing in about an hour of your time. So I'm looking forward to seeing how that works.
Okay, you spoke about the difference in assessment between experts. Now the question here is, how do expert assessments correlate with HCAS values? Is there a tight relationship?
Yeah, fabulous question. So we can't know what it's going to look like with the future data we're hoping to get, but we did analyze that, or not myself personally, the original HCAT team did compare HCAS to HCAT numbers, and there was a decent, I can't remember the exact R-squared value, I apologize, but there was a decent linear correlation, but there were places where they were misaligned. But that was a previous version of HCAS at, I think, the 250 meter resolution, so we're at a much higher resolution now, which is great. And so it'll be interesting to see if we can get stronger ties. And we're also continuing to look at whether or not the calibrated or uncalibrated version of the data also shows stronger relationships. That's something we want to explore further as well.
Beautiful, thank you. Rebecca, one for you. You highlighted various teething problems. Do you now consider a beige machine a mature product or still in prototype build phase?
It's pretty mature, yeah. We're currently going through a process of testing and it's had some what they call penetration testing to check on security levels, and so yeah, I'd say it's pretty mature. That site that I showed, that last site, is currently not released. It will be released in about a month, and that's when we will be satisfied that it's mature. Yep.
Perfect, thank you. Geoff, one for you. Are the data for individual taxon available or open for download-use like other Tern data? What information-attributes you capture for each taxon in TSF/TSX?
Yeah, so the data are available. We call it our aggregated data, so it's not the raw data. As I mentioned, we've got some protocols around data security. A lot of these sites are quite sensitive, of course, but we release the time series. So for every population that's been monitored, we give the values of the actual metric. So let's say it's the number of calling frogs, and some information. We give a citation and various bits of information about that monitoring program for that particular site and species. So that aggregated data is available. The coordinates are redacted and other sensitive information is redacted. But it is available, and we really want to make use of it. It's an extraordinary resource, really, for understanding biodiversity change in Australia beyond what we do at the TSX, which is just produce trends. And we've got a project this year to look into ways that we might be able to make better use of that data set for understanding Australian biodiversity.
Perfect. The last two questions, don't submit more. One for Pete. Are there any other countries following a similar approach to what you have pioneered here in Australia with respect to biodiversity markets?
Look, I'm going to have to say I'm not an expert on that. If you want a short answer, the script is that this is an international first in having a legislated voluntary biodiversity market. So that much I know. I mean, it's a global key point of interest for a lot of countries of how to make this sort of stuff happen. So I guess a lot of countries will be looking at what we're doing if they haven't done their own yet already.
Thank you. Rebecca, you are the winner of the last question. What do the next 5-10 years look like in terms of satellite capabilities in Queensland government? So what do the next 5 or 10 years look like in terms of satellite capabilities in the Queensland government?
So do you mean capabilities for the satellite data, or the sort of products that we might produce?
It's not clear. I authorize whoever wrote here, Isabel, is there any? Yeah, it's sent.
I'm not sure I'm qualified to...
Make it about products then.
Yeah, well, I think like with a lot of government agencies, we're restricted by, things like FTE caps and that kind of thing. So whether or not we're able to produce new products is a bit restrictive. There are some new products coming through the pipeline. We have some biocondition sort of style models and land condition kind of models. Fire severity is something that we're looking at as well. So there are some new products that are potentially coming through that are relevant to Queensland. I mean, that is the thing about it is they're all Queensland products, Queensland-wide products, not national, but yeah.
Perfect. Thank you. Well, with this, we are 3:40, happy to a couple of minutes over for our tea break. So please join me to thank all the speakers. It has been a really great collection of stories from the ecological to the social to the economic benefits that can be derived from Tern, from these many years, from the humble beginnings that Rebecca described in terms of unstable things up to what you all have shown here as the creative use of Tern and the good stories to tell. So thank you very much for the presentations.